those three. Okay, so and we say that so the big data is something everywhere right now. So we can see that it's not only from social big data, communication, creative scoring, and everything like health data, right? So, but we know all the big data come out from three sources. The first one is from the government. So government has lots of sources of data. Second one is enterprises. So the company generates data. The third one is individuals who share their opinions, everything on the internet. So which means that it's open source in internet. So this is the big data. Okay. So now we are talking about what's going on in China about big data. China is working on big data since the year 2012. So 2012, right after USA announced the big data strategy. So China has getting into the situations over there. So we transfer the big data. So from the former ideas, which we call the data mining, data analysis, data warehouse, and business intelligence, business analysis, and so on. So for example, we hold the Xiangshan conference. This is a very, very important conference in China to discuss those ideas. So in the Xiangshan conference, we just give you one example. On 462 Xiangshan conference, which we held in May 2013. So we have not only for the big data formal definitions, just like USA over here, but we also have a very, very important definition for the government officer or policy makers about what's going on with big data. We see the big data is a new type of strategic resource in the digital era, and the key factor to drive innovation, which is changing the way of human being living and production. So you can see that. So this definition which we use has been more than 10 years now, and has a very big influence on the policymakers in China, and also have some influence on international stages as well. So in order to let our friend, our international friend, our colleagues who knows what's going on with big data. So in year 2017, we published an article in a journal. It's called Annals of Data Science. The journal, the paper is called How China Deal with Big Data. So this is what we call is China Big Data Strategy. Is from 1, 3, 10, 19 strategies. That's for China's 13th 5 years, national planning. So we have the top-down design over here, the top-level design for the big data. Then we have three platforms around that. The first one is interdepartmental data sharing platform. So this will be something we build up for 62 Chinese national level of governmental department, as well as 32 provincial governmental platform. So we link the data together so that they can share the governmental data. The second one is we have the opening process is called National Data Opening Platform. So which means that we open data step by step from the central government to the provincial government. The third one is the internet-based national data service. So this is a service platform. So this is open to the public and also to the industries and so on. So around them we have 10 big projects. 10 big projects is called systems, right? So system projects, and each project supported by different governmental branches. So this is a national plan. So that's the idea. So this has been done for 2 years ago. So this is something happened 2 years ago for last 7 years and so on. But now it's still going. So now I give you first case study. Hello? Is that okay? So I see some voice. So any questions from people, or I should continue? No. So I continue, right? Okay. So I'm talking about case one. So all the cases which I share with you are cases which we contributed, we have done. So, when China has something is called pandemic, as we say, COVID pandemic, started from the January of 2020. So after 3 weeks, so our research center work with the Chinese Center for Disease Control and Prevention, is called, DCP, right? So, and Hong Kong units for the university, laboratory. So with 3 units work together by use the patient, who are in the hospitals to see what's going on with their experience before they get into the hospital. Okay. For example, so if they have contact with some group of people from 7 different groups and 4 different public, environment. So to find out, to put those parameters into traditional model to see how the disease will expand, when it will be over. So in this way, we will see how those things going on, when we should recover the work for the societies. So we publish this paper, you can see that. So after 4 months, so the paper formally published in a journal is called E-Clinical Medicine. So this is one of the Lancet journal. So this the time is May 2020 first, I believe. So this is very, very important because why? So you look at this page over here. So we did data analysis for those 6 cities in China. The first one is Wuhan, then second one is Beijing, the third one is Tianjin, the fourth one is Hangzhou, then the 5th one is Suzhou, then the last one is Shenzhen. So Shenzhen near Hong Kong. So you can see the blue line is our predictions, and all the red changes will be something happened in the hospital. That's real data. And we made 6 plannings for each cities to see what time is good for them to recover the society, to open the society. Okay, so we will see, for example, this is called trade-off analysis. If you are going to, open the city, for example, like May 1st, so you may have about 600 people in the hospital. That will give you pressure for the society. If you open it up after 2 weeks, so you may have 50 people, right? That will give you very little pressures from society, but you will get back GDP for very small amount. So this is called the trade-off analysis between the society infection and the GDP development. So this become very, very important, basis for Chinese government to see when the, society should be reopened. So this is the case 1 about big data. Okay. So this is again about the papers. So for the time being, so I just continue. So now I turn my attention to the concepts of the big data analysis. For example, we have 3 principles. The principle 1 is called big data analysis is decision-making process. Okay. For example, if you want to find out, your high-ending customers, or for some, this marketing project. So you may have the data set for about 500 variables. You are not going to use all the 500 variables, but you choose some of them to use. So how do you choose? For example, you choose 100 from 500. So how do you choose? Selection problem itself is not a computer science. It is a business problem. Okay. So start with business problem. Second, you have to transfer all the data into the formalized stuff like normalizations, right? So for example, the data could have 2 digits or 3 digits, or even the long, structure. For example, like photos, like the text file, and so on. So you have to transfer them into the unified, into the same format, so that the computer program can accept that. Okay. The third one, you just put into algorithm. So this part only is for computer science. Okay. You can use your own algorithm, or you use some people's, algorithm by purchasing or whatever, right? Or in-house or out-house. So then you analyze data through the computer, so you will see the results. So results were changeable with people and also with situation. So what does that mean? For example, if this analysis is talking about the stock market, so suppose you do not play stock, so for you, it's not knowledge at all. So that's changing with people. So if even you play stock, so the information for today is not good for tomorrow, it changes with time. So what I want to say that is at the very beginning and the end, so both sides, so from beginning to end, so both sides, they are the management problem, not the computer science problem, okay? That's very important for big data analysis. The second one, so you have to follow the machine learning, situations, which means that each model has a lifespan, okay? For example, by observations. For credit card models, which you use every 4 months, because data change, you have to relearn the model. So model will not, effective. So basically, it's expired, right? So the second for insurance price, you should relearn the model every 3 months. For stock market, so you have to do that every afternoon when stock market closed, like today. China now is about 4 o'clock, so market is closed. So you have to do the analysis for tomorrow. So that's the idea. Okay, that's called machine learning. So the third one is even more important. So this part means that, so, we see that, so many people thought data mining analysis is just look at what's going on, doesn't matter, it's structured data or unstructured data. You just use analysis to find out the knowledge. What we call is hidden pattern. So this is rough knowledge. So normally in computer science, people say, okay, so this is what I did for the user. If user disagree, I'm going to rerun the program. But actually, so users' opinion are very important. So because this decision makers' opinion should bring into the process to justify what kind of knowledge you should use. Because this process is T2 process, is second order problem. So the first order problem is data mining. Second order problem is try to put the decision makers' ideas into the process to screen what's going on, what they need. So the result will be decision support. So that's so for example, you can see that when we take derivatives in mathematics, the first derivative is maximum minimum points, right? The second derivative over here is called the change of slopes. So you can see change of slopes is much more important than maximum minimum points in terms of understanding. So same thing in data mining, we have a T1 and T2 process. So this is called intelligent knowledge management. So that's the 3 basic principles. Okay. So we are talking about the 3 challenges for the data analysis. The challenging one is, so if we have this data giving, it's called unstructured data. We have to transfer those data into structured data. So that means our algorithms has been based on structured data. So that's how we have to transfer them. How to transfer structured data, unstructured into structured data. So that is challenging one. So that's the first challenge. Actually, for those of you, if you're doing the algorithms, you will spend lots of time to do this, right? So which I just discussed before. The second challenge is, is complexity and uncertainty of the data. So this means that, so just like, let's say, blinds and elephants. So if we have 7 blinds who want to touch elephant, because they touch the elephant is too big, each part have different opinions. But now the big data is the elephant. How can we recover the real big data? So that is very, very important for the, the situation we have. That's challenge 2. Challenge 3. So we know that. So we have data, structures and verse decision structures, right? So the data structure, we think about that. We have structured data, we have semi-structured data, and we have non-structured data. So 3. But you think about decision process, the same thing. When we just get a first job, when graduate from university, so when we write the first report, we write a report very, very precise, okay? So when you submit your report to your supervisor will think this part is good, that part is not good. So they are going to make a revision. That's called semi-structured decision making. So if you go to like a CEO, the CEO say yes or no. That's long-structured decision making. So that's how. So we want to see how the data structures versus decision structures that will become the future analysis for the challenges of the data analysis, according to our understanding. Okay, so that's two things I have reviewed with you. Now we have to look at the scientific understanding of big data. So some people thought the big data is the whole population. It is not right. So big data itself is large sample analysis. So the larger sample is, the better, the more robust the analysis will be. So which means that if I analyze the data in terms of 10,000, which is better than 1,000, which is better than 100, which is better than 10, okay? So more data is better. So that's the idea. That's a large sample analysis. Second one is we are not going to only find out a rough solution or rough solutions, but we're looking for the accurate solution. Of course, in order to get an accurate solution, you have to get a rough solution first. Third, so the data mining process has a goal to predict the future. That's how we are looking at the reasoning, not only for the correlations. Okay, so those three are scientific way. So big data is a new scientific, approach. Or we could say that. So this is the rules we have to take a look. Okay. So now I'm turning my attention to the second one, is called algorithm or intelligent algorithm. So in general, we can say that all the mathematical tools are the algorithms. Okay. For example, statistical analysis, deep learning, which is used for AlphaGo, for ChatGPT, right? So hash functions is used for blockchain. So those things are just ideas. So every mathematical tool can be regarded as an algorithm in general. Okay. So, but what does it mean about algorithm? What's the central ideas? So the key ideas or the basic ideas for algorithm, just like this. Okay. So basically, so we just want to separate the data when giving the data. So we are going to, for example, use group 1, group 2, separate data. Then we are going to make mistake. The mistake could be type 1. You make the, for example, you make the band as good, right? So as some of you will recall in statistics, so we call you treat let's say good people, you treat bad people as good people. That's type 1. Type 1 is error, very easy to correct. Okay. The type 2 is not easy to be corrected, which means that you treat good as a bad. So that means, so all the data analysis has same goal, which means separate data by reduce type 1, type 2 errors. Okay. When you reduce them, the accuracy is increased. Okay. I just give you simple ideas over here. This is my chart. Okay. Maybe you have a better way to understand what I'm saying. So this is just like a 38 parallel line in Korea, right? So divided North Korea, South Korea. So if we say this circle is North Korea, this circle is South Korea. So if you go to South Korea, you can go to this place is called DMZ. So which has a 2 kilometers wide area is called DMZ area. Okay, that's a 4, the west is 4 kilometers. Okay, so you see that, for example, if we look at those 2 points, right? So this point is close to the line of 38 degrees. So to here, that's alpha. Okay, if we minimize alpha, we will make this circle towards to loss. Or we are going to maximize the data, this point to its adjust the boundary, maximum beta, minimize alpha, will make the circle to the left, make this circle to the right. So that's the idea for type 1, type 2 errors. Okay, so all algorithms has such ideas, so which we can see. So this is very important. Now, let's see, what about the computing platform? So computing platform basically is storage, the analyzer for data, the mainly realized by internet data centers, cloud computing platform, and now we have your intelligent computing platform, it's called GPU. Okay, so we have 2 kinds of formations. One is centralized computing, like a supercomputing, cloud computing, or distributed computing, like computers, like a PC, or mobile phones and so on, right? If you look at a computing platform, they have 4 units over here. So they have first one is frame, we call machine, right? Machine like supercomputer. The machine will consist of chips and operation system, application softwares. So 3 things together, right? So, and you see now we have a hot topic about this, how to bring the supercomputers. So I will bring your attention later on. So anyway, so if you look at this construction of a computer power network, so this is something China is think about recently. So because when you computing power always the important resource for the people to use, right? So you do not have enough computing power, right? Even we have so many supercomputers, so we still have to construct to see how we can utilize them, just like we utilize electricity grid. So we put them together as a multi-party resource, integrated models, so that we can have an effective way to utilize them. For example, we can converting, let's say our data, from Inner Mongolia, for the, Shanghai cities, for example, right? So the integration of existing inventory, computing power resource versus how to establish a new computing platform. That's a very, very important job in China. Okay. Now, I'm going to turn my attention to the history. Okay. I will try to make this short. So, what is history? If you're looking for history, so the history is just like this. So, 1761. So we have Richard Price. He published his papers over here. You can see at that time. So he just used his handwriting to calculate the various and let's see anyway. So about this statistics. So you can see that. So we have each row as a records of the tax payers in Britain, in the British some area in England. Okay, each column will become variables. So this is what I want to call the Richard Price table. Okay, Richard Price is a very famous guy. So basically, some of you may know that he was the guy who created the tax system for England. He was also the guy to have women movement for the society. So, but he was also the great statistician in England. So this is the early thing we can see from his research paper. So I would like to say that. So this is just like our multi-dimensional table which we use now. So you can see. Only difference is we have hundreds of thousands of rows, hundreds of thousands of columns right now. Okay, so that's the Richard Price. So then we can see that in 1950s we have a database, right? First built by some company like IBM, right? So then they can start to use artificial intelligence to do the work. In 1990s, so we are talking about use knowledge discovery databases or the data mining. So then eventually we can see from last 300 years, so we as a human being analyze the data in scientific way. So far, only for about this kind of a situation, 300 years about, okay? So for last 300 years, the traditional way is statistical analysis. It's called for the data collections, mathematical statistics, and to descriptive conclusions. So that's the basic way. So that means we look at the distribution type, look at the look at expected value and the variance and so on. But then from 1950s, right, 1956, last time, the first conference for the AI. So people start to use machine learning to do the data collections, data pre-processing, data mining, or data algorithm to find out what's going on with knowledge. But those two approaches, which we mainly use, are based on the digital data. If we are giving non-digital data like photos, like images, like text files, how can we do the data analysis directly from there? It is challenging. Okay, so that's a very challenging job. So, but look at the planned computing. So that's the same thing. We start with 1950s. So remember, so first computer people built at the University of Pennsylvania. So basically, they want to solve large scale, linear equations, right? That's the idea. actually largest square linear equations is still the one we use for big data, because if we can see the matrix itself is called a big matrix, right? That's the same thing. So then we have distributed computing 1970s, right? From there. So that's after that we have a PC, right? We have PC. So that's a history. Then we go back again, clouding computing. So now we're getting into the big data analysis by using AI. So that's by using GPU, not CPU, and so on. So this is intelligent analysis. So that's what we have so far. So, and if we look at what's going on with the international, the business world. So in 1990s, go back to 30 years ago. So we use IBM, Microsoft. So they are for database. This is for operating system. But we also have big data, like First Data corporations. They control the data for 1,000 banks. Okay, that's a big data company. And as well as your backbone company like Level 3 Communication, built the fiber lines, for not only for USA, but also for cross Atlantic, oceans and cross Pacific Ocean, fiber lines. So they serve for 150 countries and regions. So that's a big one. So this thing is we call the infrastructures. Then in 2000 years, right? So we have Amazon, we have eBay, we have Google. So they start to do business because this demand from the market. Then finally, so we are getting into the big data areas with other countries. So many countries. Anyway, okay. So now this is the history. Now I want to review with you what's going on with China individually, all right? So let's see. So China has been doing this since 13th, 5th years planning. So which means 7 years ago. So then at that time, China's digital economy by the evaluations has been grown to 11 trillion yuan to 39.2 trillion yuan in 1920. So this is about GDP 38.60%. Okay, but then year 2021, even during pandemic, so it's going up 39.8 because people use more often buy everything from online. So you can see it actually, the situation is booming. So last year it has been reached for 41.5% GDP. So this is really good. So and this year we see this number even higher than that because we have 1 more month to go. Okay, so this is a situation of China. So this is from one of the statistics, right? Okay, so and if you look at those ideas in terms of digital industrializations, so by details, so you can see that. So the revenue of internet enterprises is 12.5% by 2020, and 29.6% for the big data industry. So for industrial digitalization transformation is also going up. So it's become 49.5% for the equipment and productions and so on. The new business model come out very quickly because young kids can do lots of business online, right? So there are dozens of stuff, through internet. So you can see something totally new compared with 10 years ago. And we have innovation and development for the regional digital economy. So China has 4 metropolitan areas, so which they have about 35% of GDPs of China. The first one is Beijing area. It's called Beijing, Tianjin, Hebei. The third one is Yangtze River Triangles or Delta, which is the Shanghai area. Then Canton and Hong Kong Macau area. So that's called the south area. The fourth one is inland Chengdu and Chongqing, twin cities. So those 4 regions are growing very, very quickly. And it's very interesting. You can see that, let's see, except the Beijing area, so Shanghai, Guangdong, and Chengdu areas, they used to be very agriculture-oriented area in China in the ancient time. So now they transfer them into industrialized age, so very quickly. And then the third one is integration and sharing of government information system. And China, the Chinese government now provides much better service for the citizens. For example, if you go to one buildings for the city of government over there, you can handle everything for the social service. Even many things can handle by your cell phone. Okay, so of course, improve people's lifestyle. So which is like online education, online office, online shopping, and so on. So that's all the changes. You can see this page gives you some ideas about what's going on with digital economy of China. Okay, so I gave you a case study 2. So case study 2 is all something we have done for China. For example, we did a national credit scoring systems for China for all 1.4 billion people. So we calculate their score by their credit scoring to see what's the situation they can get a loan, they can get business loans, whatever, mortgages from the bank. So that's what we did. Okay, and now if you look at those countries, USA something is called FICO score, China is called China score. That's my contribution to China. So anyway, so this is the models which we have. So we have 4 models. If you look at a case score, right? So case score, many of you are familiar with case score to say goods versus bad, right? So this version is very, very good. It's even higher than the number of USA, all those 4 models. Okay, I have a comparison over here. You see, in USA, by FICO score, the average is 678. Whenever you have a 620 score below, that's called subprime. That means you got a problem, which means that you borrow money for living, you also borrow money to buy your house. Okay, when the crisis is coming, so basically you will go bankruptcy. So that's the situation. And then look at Chinese score over here for 4 models, much close to USA. Even so in China, so we have a difference between the US dollar and the Chinese yuan. So, but however, people in China still use their money to buy house and to buy cars right now. So just like USA. So that's the situation. And then you say FICO score distribution in USA. So you have 8%, 5%, 2%. They are the people have problem. 50%. Other people are good. So this is a +1 distribution, right? So, and here is the Chinese distributions for 4, much similar to that. So that's the similarities, so which we did. So now I'm talking about what's the condition for China to develop digital economy. So the first advantage which China has is, so we have very good social systems, so which we build so many laws and so many regulations. Recently, we just built a national data bureau for the whole country. And we also have something like data 20 regulations. So to let people know how to classify the ownership of data, how to use the data, how to make money through data, how to transfer money, how to transfer data into the capital. Okay, so that's very important. So the second advantage is called huge scale market. So we have about almost 1 billion people to use the internet, 1 billion people, okay? And we can produce almost everything, so from industrial base. So, and actually, so, I see many of you, because father invited me, so some of you who are my friends. Yeah. So, well, I guess someone is talking now. Okay, would you please turn off your, microphone? But anyway, I see so many Russian friends today. Actually, Russia helped China to build an industrial base in 1950s. So that's one important contribution from Russia. So, and the third advantage is we have a digital technology research and development. The major stuff over here is, the average age of, the active researchers, their age is about 30 to 35. So they are very young. So this is very, very important. So those things will allow us to push the digital economy develop so quickly in the future. Okay. So, but however, China digital economy still have some problem like challenges, right? So, for example, the data is big but not strong, because we start to use the database for example, like smaller business. So just right now, but for example, other countries like USA, like Japan, like Germany, even some companies in Moscow, Russia. So we use the database a long time ago. So that's how. So we are so slow. We are so so late to use those advanced technology. So we have to improve that. Okay. Second, we have to improve our supercomputer too. Even China has most number of supercomputers compared with other countries. It has been #1. But however, the computing power totally together is under USA, even under Japan now. So we have to continue to push on this. I just gave you a ranking of supercomputer. For example, this ranking of supercomputer, so we can see, China's #1 computer now become #7 in the world. Number second become #10 in the world. So US computer, Japan, Finland, Italy, right? So US computer again. So China need to push more. So for the computing power, only for the supercomputer, but of course we have a clouding computer. So total computing power of China is #2, right after USA. But it will go very fast, even higher than USA in next 2 years. So anyway, so I just gave you some good news too. So we are very innovative. By this is a case study which we carried out by ourselves. So we are using our Chinese supercomputer to analyze China's financial future exchange data. So this is the first thing we have done in the world. So because we use supercomputer to run the largest scale data, that's a huge data, so big data, to see how the financial market should develop in the future. So this is what regulation we should have done for that. So this is very important. Okay, so now, change it too. So we still have some technology we have to take care. For example, we may develop our own, operation systems. Okay, this is on the way too. I believe Russia has its own operation system. So in terms of, Microsoft, so we should have some other operating system. Maybe we can write some operating system, develop that from Linux directly. Okay, this is some, new product coming out from China. So then we should, design more computer chips. So China is a market to use the computer chips, 70% of international market. It's huge. It's about 500 billion yuan market in China. But when China and the US has some problems with trade stuff, right? So then there's some regulations which we cannot buy good computer chips from USA. So we have to think about how to develop our own. So this is again. So hopefully the world will getting better. But however, we have to do something by ourselves. So anyway, so that's challenging. Then challenge 3 is to talk about the openness. So we have to open our society to the rest of the world, build more international, community or international associations for the big data around. For example, for those, international organizations, if they have existing, so we should join them. If we are in, we should try our best to, help each other. So if they don't have, we should build by our own. For example, our ITIQM is one, so we have to build for international friends, work together. So those things, we have to keep our, society as open to the rest of the world. So this is the third one I'm talking about. So then the fourth one is called 东数西算, or we call the current data from the east to west, empowering the digital economy. When you develop digital economy, you have to find out the infrastructures, right? So Chinese development, different from USA. The US develop economy from both coasts, east coast to west coast. So naturally, people think about try to store the data in the middle part of or south part of USA. That's very natural. But the Chinese cities, well developed.
Yeah,
so, the coast cities, for example, like Guangzhou, like Shanghai. So there, let's see. So, the cost of for the supercomputer, for the computing power to use electricity has been very, very high. So it's about 4 or 5 times higher than Inner Mongolia, for example. Okay. So that way, so we should store some data. We are not going to use quite often from Shanghai to the Inner Mongolia, because Inner Mongolia not only have a power, but they also have wind power. They also have solar powers, right? Those green powers. Okay. So that's the idea we have to think about for last 10 years. Finally, we made a decision. This strategy is called 东数西算. So this is strategy to channel, to share other channels, computing resource from east to west, which involves constructing 8 national computing hubs and plans for building 10 national data center clusters. Okay, so let me show you these clusters for this our 14th, 5th year plan right now. So for example, you can see this chart. So this is the Beijing area, this is Shanghai, this is the Guangzhou area, this is Chengdu, Chongqing. So those 4, metropolitan areas try to store their data in Inner Mongolia, Ningxia, Gansu, and Guizhou. So that's called, the 8 computing power hubs with 10 clusters. So this is very important. So I have been working on this to help them to build this kind of, a large, system, for last 2 years. So this is very important because we try to handle relationship for 4 different type of things. The first one, we will handle relationship between central government with local government, like Shanghai government. We will handle second relationship between, the provincial government, like Shanghai and Inner Mongolia. So for example, Shanghai said, I store the data in Inner Mongolia. Why don't you give me your quota about the green development to Shanghai so that we can develop something else, right? So, and the Inner Mongolia will say that, why don't you, create more, let's say, jobs, employment for me, right? So that I can gather more tax, right? So that's the second relation. The third one is the builder, which is corporations. They have some problems with local government to see, if they get a land from local government, so they have to pay tax, right? They have to create, employment as well. So then the fourth one is between those builders, right? The corporations, they have to handle their relationship. So if we know how to handle those 4 kinds of relationship, and this big project will be going very well. That's very important. So we have to massage there, okay? And those things related with, the big data. So you can say, the big models like ChatGPT, right? So ChatGPT need to use those computing powers, right? So, but it's not easy to use ChatGPT. This is just examples, right, for international market. If we want to do, let's say ChatGPT environment, or we call the metaverse. So we need to have for 200 people, situation for all the digital people, right? So we need to have a 39 1000 P, that's supercomputer, to support this environment. It's difficult, okay? So ChatGPT and metaverse require heavy computing powers to support. So this is economically not effective. So, but however, it is still good because it created so many different jobs for us, right? So we are thinking about that. It changes our thinking, everything. So, this is what we just saw that. We just say that maybe we should look at high computational density, ultra large scale computing power, and ultra fast, training speed, and to face how we can, combine, big model strategies with our carry the data from the east to west. So this is a very large scale ideas. So, because my time is running out, I have to use a few minutes left for you to use, okay? So the Chinese national, let's say, Congress, something like Congress, is called, Chinese Standing Committee of the CPPCC. So they invited me give a talk, 2 years ago, exactly 2 years ago. So over there, after I give a talk, I gave them some suggestions, to see how we can take advantages to develop, high quality of Chinese, digital economy. Because of time, so I'm going to, skip this part. But however, the important thing is the Chinese government require all the local officers, they have to be evaluated to see how they are doing to implement their local digital economy development for this year. Actually, they have to figure out that kind of evaluations by end of this year. So this is very challenging to them. So government push local government do a lot of things, which is good. Okay. So finally we see that why we got a big change, because our human being got a good idea, transfer the digital system, a decimal system into binary system. For example, like what Leibniz did, the German mathematician, right? But his paper is not published, in 17th centuries, unless he found out what his idea is similar to Chinese ancient, ideologies called Yi Jin. So these ideas come from the French missionary whose name is Joachim Bouvet, who was an advisor for Chinese emperor. So he said, what you are doing is similar to what Chinese Yi Jin said. So, Mr. Leibniz was very happy, say that I found the connections between my contribution to, what's going on with battery systems. So this is the way changing the world. But now we have to going back to see. So the battery system is battery system really good for us? Not really. Maybe we should look at multiple systems to redesign the computer, because the computer chips getting smaller and smaller. Eventually, now recently the news said that some company has been doing for three NM, small chips, right? So now we cannot find the material to support even smaller after that. So we have to redesign our battery system into multiple systems, right? For example, I know, our Russian scientists tried that in the years past, right? For three value systems, which he didn't succeed. But, Japan tried that for quasi logic, systems about, multi-values. So it's also didn't go through. But in the future, we have to think about that, how to do that for the current chips, to redesign that. So that means, so by that time, so not only for the material, but also for the multiple systems, maybe we can go back to, multi-decimal system again. So that could change our future. So this is just my ideas, my imagination. I believe this will come true after, some years from now. So final page. So anyway, so we know Chinese history has Yi Jin. Some people say more than 5,000 years ago. But we didn't create a battery system until, Leibniz did, in the 17th centuries. So China has something is called, Gou San Gu Li. So this is the theory which China said, actually after 500 years, this has been represented by the, West people is called Farmer-Goring. Theory is called 3 square plus 4 square equal to 5 squares. But this is after 500 years from Chinese history, but China didn't use, Arabic letter to show that. Okay, what I want to say that if we do Chinese digital economy, so if we combine Chinese culture with digit, with data, so with Chinese culture, this simple function will give us digital China. Okay, change everything by the data. So this is the end of my talk. So I have some books, during pandemic, I wrote this books, just published last year by Springer, with 700 pages about advances of big data analysis. For those of you, if you want it, you send some email to me, so I will give you free copy. Okay, so this is some contribution I made. Okay, I have a very popular book. This book has been used for 28 international campuses. So for my book, okay. So this is the end of my talk. So sorry to take too much time. So I still have about a few minutes to answer a question if you have at least 1 or 2 questions.